We're back for a third installment of our dimensional analysis series. This time, we will be working with some metric units, SI units, but also some units that are not. In addition, this is one of the more complicated types of dimensional analysis problems we'll see because we're working with derived units. I've got miles per hour, and I also have meters per second. And so, how do I go about solving that using dimensional analysis? Well, some things don't change. We start with the first number that's given to us, 34.5. But watch this, and this is key. When I write down my units, I need to recognize that miles per hour really means miles divided by hours. And so on my horizontal line, I'm going to separate miles an hour. It's miles divided by hours. So one part of that, hours, goes onto the bottom half of that line. I really treat this as two separate problems that I do in the same space. I have a distance issue. I need to get from miles to meters, and I have an hours situation as well. And so I need to change that, or a time situation. I need to change that from hours to seconds. Let's do that first. See how I have hours here on the bottom? If I want to get rid of hours, it really needs to be on top so that it will cancel out. If I want to go from hours to seconds, I'm probably going to go through minutes first. So I might say something like this. In 1 hour, there are 60 minutes. And then I might say 1 minute is 60 seconds. Half of my problem is done because if you look, I can cancel now hours with hours, minutes with minutes, and I'm left with seconds. And that's what I want. Typically, students aren't necessarily aware of the conversions between miles and meters. If you're a track runner, you might know that it's close to 1,600 meters in a mile, but that's not an exact conversion. So I'm going to give you a few things to think about. These are probably conversion factors that I would give you. Number one is there are 5,280 feet in 1 mile. The second conversion that I would be likely to give you is that there are 2.54 centimeters for every 1 inch. And if you had those two pieces of information, I think you could get there. Let's see how it would look. First thing I'm going to do is change from miles to feet. Notice how miles is up here on the top of the line. So I'm going to put it on to the bottom of the line of the next available space. I'm going to say 1 mile is 5,280 feet. And even though I didn't give you the conversion, I think most of you would know that in 1 foot, there are 12 inches. And then I could say in 1 inch, there are 2.54 centimeters. That was the conversion that I gave you before. And finally, I can convert from centimeters to meters. Centi is 2 decimal spaces away from meters, or the base unit, on our Greek prefix chart. That's a difference of 10 to the second, or 100. There are 100 centimeters in 1 meter. So if I go to cancel units, miles cancel with miles, feet with feet, inches with inches, and centimeters with centimeters. And I'm left with meters in seconds, meters over seconds. Now I have to calculate that all out to see what my final answer is going to be. A good rule of thumb, by the way, look at how many digits you're starting with That's probably how many you should end up with in your answer. It's not a perfect rule, but until we know something about significant figures, that's what we're going to use. So on my calculator, I say 34.5 times 5280 times 12 times 2.54. And then I'm going to divide. I divide by 60. I hit divide again and 60 once again. And I divide by 100. When I do that, I get an answer of 15.4 meters per second. And that's all there is to it. We're going to have one more video about dimensional analysis coming up. See you soon.